Hi kids, received some questions about the assignment. One of the questions I received through email, but it would be better if it was in the discussion thread, but nevertheless through email. What is the force of gravity on a space station when it's on the surface of the Earth in part A? Well, if it's on the surface of the Earth, you can just use this equation here. We know the mass of the space station. We know that negative 9.8 newtons per kilogram is the gravitational field strength near the surface of the Earth. For part B and C and D and the rest of it, you're not near the surface of the Earth. You're far from the surface of the Earth. The space station's way out there. So you have to find what the mass of the Earth is. That's a known quantity. I've written it in green for you. Then we have right here the equation you need to use. Force of gravity is equal to G, big G. What's up, big G? The universal gravitational constant, the mass of the Earth, which we looked up, the mass of the station, which we're told in the question, and how far apart they are from each other squared. Now, in the first one, they tell you that it is 128,000 kilometers away from the space station to the Earth. That's how far apart they are. We then convert this to 1.28 times 10 to the 5 kilometers. Then we remember that kilo means 10 to the 3. When you multiply powers with the same base, you add the exponents. So we get 1.28 times 10 to the 8 meters because we always use meters. We don't use kilometers. That's not what we use in these questions. The next one that I was asked about was number 9 from chapter 3. And Sirius is a star, all right? And its mass is given to us in the question. There it is in the blue. The radius is given to us in the question, right there in the red. And then there's an object on the surface of it. And we're also told its mass, 1 kilogram. Well, the radius is how far they are apart, right? So radius would be here as well, is how far apart they are center to center. So that's how far the object center and the star's center are from each other, 2.5 times 10 to the 9 meters, and it's in meters. And we know the mass of each of them, and we can use this equation to calculate it. I hope this helps.